Welcome to this YouTube video, and in today's video we are going to learn about natural language processing with PySpark. And in this video we are going to learn about a simple basic building blocks for natural language processing. Like we are going to learn about our Tokenizer, we are going to learn about StopWord Remover, we are going to learn about TF-IDF Vectorizer, and we are going to learn about count of Vectorizer. And in the next video, we try to solve a real world problem using Kaggle dataset, and we try to classify the news using PySpark and obviously natural language processing. So the first thing we need to install the PySpark. So for installing the PySpark, it's really simple. All you need to do, just run pip install PySpark. Okay, like I have already installed it, so I'm not going to run this cell. Once you install it, then we need to import PySpark, right? So for importing the PySpark, and we need a Spark session. So for that, what we can do, we can just simply say from PySpark.sql, we need to import a Spark session, right? And then we need to create a Spark session. So for creating the Spark session, it's really simple. We just need to call a builder.appName. So let's just call it NLP learning and get or create, right? Okay. So as you can see, our PySpark session has been created, right? And we can also use it on web UI if you want, but let's not do that. Okay, the next thing, we are going to learn about Tokenizer. Okay, now the first thing is what is Tokenizer? As a name suggests, it will going to take a sentence and it will going to change into the words of tokens, right? So as an example, if I have like a sentence, something like this is the best NLP video, right? So if we tokenize it, then it will become this, comma, is, comma, the, comma, best, comma, NLP, comma, video. So it will going to take this sentence and it will going to split it into the words, right? So like for Tokenizer, first we need a data frame, right? So for creating a data frame, what we can do, let's call it df like spark.create data frame, which is going to take a list of tuples, right? So we need to pass the list of tuples. So let's call it 0 and let's call it hello. I am happy to learn NLP. This is our first sentence, and let's just create a second. I want to learn about PySpark. And I am very interested in machine learning or NLP, right? And after that, we need to pass our columns. So for columns, let's call the first one as an ID and second sentence, right? And if we show it, df.show, that means just show only the first 5 row, and we don't want any truncation, false. So it will going to run, as you can see. Yeah, so we have our IDs and we also have our sentence, right? Now what we want to do, we want to take this sentence and we want to convert it into tokens. As you can see, up, right? So for converting the sentence into token, we need to import our tokenizer. So for that, from PySpark.ml.features import tokenizer. Okay, right. Now let's create a tokenizer object, and which is like tokenizer. This tokenizer is going to take two things. The first thing is the input column. The column we want to tokenize, which is in this case sentences, and our output column. So let's call it tokens, right? Okay, and then we need to transform it. For that, what we can do tokenized equals to tokenizer.transform, and we need to pass our data frame that we want to tokenize. So in this case, we want to tokenize DF. What is DF? DF is our data, right? So let's just try to show it. Tokenizer.show, and if I run it, as you can see, like given a sentence, like we get our tokens, but let me just do truncate equals to false so that we can see the complete tokens. So as you can see here, right? So like the sentence we have is like complete sentence, and we created the tokens out of it. So as you can see here, right? Now just try to get the length of this tokens, right? We can just simply see, like we can count it. It's like 1 2 3 4 5 6 7. So let's write a function to count our tokens, right? So for that we need to create a UDF function, which we call the user defined function. So for importing that, what we can do, we can just say from PySpark.SQL.function, we need to import UDF, which is user defined function, and we also need to import column, right? Not collection list, we need to import column. Okay, now let us create let's create a user defined function which is going to count the number of tokens that we have. So let's call it count tokens. Okay, so for creating the UDF, it will going to take a lambda function. So I can show you, look, this is going to take a lambda function, right? And yeah, also one more thing, we need to import the type, right, that we want to create our tokens. So for that, it's like simple SQL.type, we need to import our integer type, because we want length to be an integer, right? Obviously. So we are going to create a lambda function which will, let's say, word, and we want to count the length of word, and which will be an integer type, right? This is our integer type, which is a function, right? Now let's just count our tokens basically, right? So let me run it, and for counting the tokens, we are going to take this data frame. So it will like tokenized dot select. We want to select our sentences, and we also want to select our tokens, and we want to create a new column with it, which we can do with columns, and we're going to call it length, right? And we want to use count tokens, which is going to take a column name. So the column, and the column that we want to pass, it's called tokens, and we basically want to show it. So yeah, as you can see, we have a length of 7, we have a length of 6, and we have a length of 8, right? So if we count it 1 2 3 4 5 6 7, so it is the same as 7, right? So that is how we can do a tokenizer or like tokenization, right? But there is something called Regex Tokenizer which work pretty good. So let me show you what I mean about it, right? So let's say I have a new data column. Let's give it an ID 2, and the data column that we have is like, I don't know, like this is some kind of list. Okay, so I run it. So see this, okay, this and if I try to tokenize it, you can see this is not going to tokenized, right? Like it is tokenized, but if you get the length, it is going to give us 1, but the length is not 1. We know that, right? The length is 1, 2, 3, 4, 5 and 6. So for this what tokenizer does, like it will going to split the sentence into the spaces. So like this, right? But what if we have a sentence like this? How we can tokenize it? So for that we need to use our regex, right? And like it's pretty easy. Let me show you what I mean about it. So first we need to import it. So like from PySpark.ml.functions import regex. Okay, that's not okay, it's features. Import regex tokenizer. Let me call it reg token, right? It will also going to take the same the input column and our output column. So for input column we have a sentences, and for our output column we call it reg token. Okay, again reg token equals to reg token dot transform. We want to transform our data frame, right? Like the same as we did up, as you can see here, right? And if we do reg token dot show truncate equals to false. See, this looks same. So for that, what we need to pass here, we need to pass our pattern, in which pattern we want to like split. So by default it will going to split in spaces, but we can change it to like words. For changing it to word, we can just pass this regex format. So now it's changed, right? Now let's just try to count the length. So call it regex token, and we have reg tokens and reg token. If you run it, you should see we have a length as 6, right? Now let's just learn about stop words. So first of all, what are stop words, right? So stop words are the words, right? They are not going to give us any much information about the word, right? So in this case, this is not going to give us any kind of information about the sentence, or like 2 is not going to give us any kind of information, and these 2's also, right? So we want to remove those words, because they are not going to give us any kind of information in our machine learning model. So we just want to remove them. So for removing the stop word, what we can do, first we need to import our StopWord Remover class. So from PySpark .ml.features import StopWord Remover, right? Now for removing the stop word, we need to do two things. First, we need to tokenize, and second, we need to remove stop words. So we have our tokenized data frame. In this, we are going to use the Regex Tokenizer because of the way it's going to split the data set, right? So let's call this remover, and we need a StopWord Remover, and it will going to take again the same thing. First is our input columns. So the input column is reg token, because we need to pass the tokenizer, right? So reg token, and the output column, let me call it cleaned. Okay, now we need to transform it, remover dot transform, and we need to pass our data frame. So in this case, we call the data frame to Regex tokens, as you can see in here, right? So we need to pass our data frame, and let me just show it, and truncate equals to false, so we can see the full data. Okay, so this is our tokenizer, and this is our clean text. After removing the all the stop words, so you can see I am, like they both are removed because they both are stop words, and also I have I is also removed, to and about, and the same case in here. So that is how we can remove the stop words basically. Now just learn about count vectorizer. So what counter vectorizer will does, it will going to count the number of tokens that we have. So as an example, let's suppose we have something like this: A, B, C, D, E. So it will going to count the number of words. So in this case, we are going to get 1, 1, 1, 1, 1 because we have all of the value occurring single time, right? And let's suppose we have something like this: A, like A, B, B, C, and D. So the output that we are going to get is like we have 2 A's, we have 2 B's, we have 1 C, we have 1 D, right? So this is what we are going to get. So let me just show you. So for this, let me just make like count vectorizer data frame for just testing purposes. So for creating a data frame, what we can use a create data frame method. This will going to take a list, and then it will going to take a tuple. So let me just create a list of like the same A, B, C, D, E. Okay, and the second list that I want to create, it's also a list of A, B, B, C, C, D, D, E, E, F, F. Okay, and the column that we are trying to pass, it's let's call them ID, and the second one is words. Okay, so if I like show it to you, dot show like truncate false. I'm sorry for the background noise, like there are people, I cannot do anything about them, so just I guess ignore them. Okay, so as you can see, we have a data frame in which we have the word which are look like this, and we have our IDs. Okay, so let's just import our count vectorizer class. So for that, from PySpark .ml.features, we need to import count vectorizer, and let me just create a CV of count vectorizer. Again, we're going to take an input column. So in this case, we have words, and let me just call it output to like count vector. Okay, and it will going to take a vocab size. So 1, 2, 3, 4, 5. Let me just put it 5, and the minimum TF is I don't know, let's go with 2. Okay, now we need to fit, so let me just call it cv underscore model, which will be cv dot fit, and we need to pass our data frame, so in this case cv underscore df, and the result is cv underscore model dot transform, and we want to transform our cv df, and if I show you dot show, and the truncate equals to false. So yeah, so as you can see, in first words, like the list of words, we are going to get everything as 1, right? Because the count is only 1, like this. Okay, but if you look at the second, we have a which is occurring 2 times, so we are getting 2, and b is also occurring 2 times, like so we are getting all the values as 2. So this is what count vectorizer is does. It will be going to count the number of times or token is appeared. Okay, now just learn about TF-IDF, which is term frequency inverse document frequency. Okay, so TF-IDF. So we know how count vectorizer is work, right? It will just going to count the number of word, but how can we say if the word is occurring more than this word has the more meaning for that sentence? What we are trying to do, we try to find the inverse document frequency. So we are going to take a single word, let's say in this case we are going to take C. So we can see that C is like occurring 2 times here, right? But how can we say the C is like most important word for us? So for that, what we can do, we are trying to find its inverse document, right? So we are going to check it with the complete document, and then we are going to check if it is like occurring in complete document or not. So that is what TF-IDF vectorizer do. So for finding the TF-IDF vectorizer, we need to do 2 things. First, we need to tokenize. Then we need to use our count vectorizer, or we can use HashingTF, right, which is same as count vectorizer, but it will use hashing functions, and then we can simply find our IDF. Okay, so so we already know how our count vectorizer is works. So in this case, we are going to look at our HashingTF. So for this, let me just copy my data. So here, let me change this to IDF underscore DF and IDF underscore DF. Okay. Now the first thing we need to tokenize it, right? For tokenized, we are going to use a Regex tokenizer, right? And which is going to take our input column. In this case, we have sentences, and the output column we want as it's called rep tokens, and we also need to pass a pattern. So let me just pass the pattern. It's like / and w, right? And let me just call it word underscore df equals to tokenized dot transform. So we are going to transform it, and the data that you want to transform is called IDF underscore df. So let me just see, truncate equals to false, and let me run it. So we have a tokenized sentence. Okay, now we already know how count vectorizer is work. So as you can see up, so in this we are going to learn about how our HashingTF is works. So for that we need to import it. So from PySpark.ml.feature import HashingTF, and we also need our IDF. Okay, now for hashing, let me just call it hashing_TF, which is our HashingTF. It again going to take our input column, and the input column we are going to pass, it's called a reg tokens, and the output column, let me just call it features. Okay, and the number of features that we want to pass, like our data set is not big, so let me pass 20. Okay, and let me transform it, call it featureized, and HashingTF.transform. We want to transform our data, right? So in this case the data is word_TF. Okay, and let me just show it to you. Show truncate equals to false. So as you can see, let me just do truncate. So as you can see, we have the features as well as we have our tokens. Now what we are going to do, we are going to take these features and we are going to find its IDF, which is term frequency. So for this, let me just create an IDF. Let me call it IDF. It will going to take again the input column, and the input column in this case we need to pass features, and the output column, let me just call it IDF features. Okay, and now IDF_model, let me just fit it, IDF.fit, and we want to fit it on featureized data set. Okay, and then we also need to we need to transform it, .transform, and we want to pass our data. So let me run it. Okay, and if we see df model dot let's say show, so we have our features also, right? So let's just take only our features and our IDF, like compare. So for like comparing, what we can do, let me just call it compare, and we will take IDF model and we want to select only our features. Let me just select our sentences or like reg tokens, and let me select my features, and let me also select my IDF features, and let me show it to you to truncate false. So like we have the feature which is normalized feature, so like the value is 0.91, in this case hello, right? For hello, value is 0.91, right? And if we look, 2, like 2 is not going to give us any kind of information, we can just remove them using StopWord Remover. So for 2 the value is 0.51, right? And for learn it's 0.23. So now we can see the value is less, so which means this value is like going to give us more information about the particular sentence, right? And that is all about this video. We know about how we can work with Tokenizer, how we can work with StopWord Remover, and how we can do TF-IDF, and how we can do count Vectorizer. So if this video is somehow helpful to you, then please feel free to share it with your friends, or you can also subscribe and leave a comment if you want me to change something. And I'll see you in the next video. Thank you so much for watching. Bye.